Welcome to EGS216, Digital Logic Design at North Shore Community College. This video is intended to supplement the syllabus and help you get a good understanding of what to expect from the class. I'm your instructor, Mary Beth Steigerwald. I do have office hours. They are on Zoom, and they're listed here. They're also listed in the syllabus. You can also make an appointment to meet with me. The best way to make an appointment is via email. There is a textbook for this course. The textbook is the 6th edition of Digital Design by Mano and Saletti. You can get the 5th edition, and that should be fine, or earlier editions of the textbook. They would be cheaper if you bought them, other than going through the bookstore to get these online. So if you do that, that should be sufficient, as I do supply you with a homework package. And you should be able to get the information, the content material from older versions of the textbook. So feel free to do that. You can feel free to talk to me about that. This is a Blackboard supported class. So on Blackboard, make sure you go in and you review the syllabus. The syllabus is in the course information folder. And also make sure you go in and review the guidelines in the guidelines folder. There are guidelines for this class to help you understand what it is that needs to be done. We do meet twice a week, so that should be, help you be able to ask questions at that time as well. The module guides for this class, this class is broken up into modules that are associated with the chapters in your textbook. And within those module guides, there's the material you'll be able to find to be successful within each module of the class. Taking a peek, for example, module 0, this is really a review module. It's not really intended to be part of the class. It's a review of electricity. So the prerequisite for this class is a physics of electricity and magnetism or a circuit theory class. So this will help you review electricity notes, sufficient hopefully to get you through the class. There's a video in here. There's a slide of the video. There's also a fun video, Spark Fun. It might be more fun than what's in there. So make sure you go through and review these electricity notes. That will be very important to you, whether you're familiar with electricity or not. And again, that's in module 0. In module 1, the other modules are all structured in this manner such that there's a folder for the notes, the module learning guide, and slides associated that help to make the videos in the module videos. As opposed to doing lectures, I'd like to flip this class, and hopefully I'll be able to do that if I can keep up with making the videos. And in our class time will be spent doing teamwork and solving problems. Solving problems within teams. We will meet via Zoom, so you'll be in breakout rooms in Zoom, solving problems in teams and coming back. And each team will present a problem each week as well, their solutions to a problem. That should cut down on the amount of homework that you need to do. There will still be homework done after class. So what you're expected to do in this class is learn the material, preview the material prior to class with module videos and perhaps some reading, in class doing the teamwork, and then after class practicing again with the homework. So labs are also an important part of this class. Labs are 20% of your grade. So actually, labs are 40% of your grade in this class. And we do have 3-hour labs in this class. So there's a guideline folder within the guidelines folder, and under course information is where you get the lab guidelines. The first lab, we will meet Wednesday. The first day that we meet, we will go to Lynn. It's LE201, and we'll meet for lab. And really what we're going to do there is it's a little bit of electricity review. We'll go over the device that you will use in lab, and you'll get your lab kit that you purchased when you registered for the class. So all that will be distributed, but we will spend time in there, and you'll go through and make sure you understand how to work all the equipment, as well as learn how to use the oscilloscope. For each of the other labs, we're using the textbook for our labs. So all the labs are in chapter 9 of the textbook. So you'll be able to access that. But additionally, for each of the labs, I have notes that help, grading notes to help guide you through the lab and how to help you write up the lab. So again, make sure, for that introductory lab, make sure you go in and prepare for that lab. You're going to want to watch the intro to lab video. Um, and, there's other things in there that tell you, it's on Blackboard, that tell you what it is that you need to do to prepare for that lab. And again, this PB 503, you'll each get your own PB 503 that you'll be using throughout the semester. And then the first day, what we'll be doing is a lab quiz, and that you'll also be able to find on Blackboard. All right, so that's a little bit of an introduction to the class, as well as here, required materials. We talked about what the required materials are. This is a lab notebook. I should strike that. You are going to be submitting your reports online as opposed to in a lab notebook. So you don't need this 3-ring binder. You can do handwritten reports or typed reports. They'll be submitted via PDF on Blackboard. A digital template is optional, a way to be able to make your circuit designs. A lot of people now like to do this electronically. So we'll talk about that in lab. We'll also use Verilog HDL. You'll download a simulator for that. We'll use a free simulator. And then, of course, you'll need a scientific calculator or some kind of type of calculator at some point to do some work. So again, it's 4-credit class. The lecture, Monday and Friday, we lecture via Zoom. Again, hopefully that lecture is active work session where you'll be working in breakout teams on teamwork, which are worksheet types material. We'll be solving problems. There are 2 laboratory sessions. The lab only allows 6 students, and an instructor is a limit to 7 people who can, due to COVID, that can be in the lab at one time. So the morning session meets from 9:30 to 12:20 on Wednesday. The afternoon session 1 to 3:50. Now that's a 3-hour lab. Most digital logic labs are 3 hours. It won't necessarily always take you 3 hours, but I would plan for 3 hours to be in the lab, and make sure you get there on time. The room is LE 201. When you get to the Lynn campus, you'll have to go in the door by the big parking lot. You'll go up those stairs immediately as you pass the security guards. You'll walk past the cafeteria and then take a right, and it's in a little cubby back there. So we'll find you on the first day if you haven't been there yet. Again, the prerequisites to this course are either 211, which is a circuit design class, or Physics 203, Electricity and Magnetism. There are some of you who are currently taking PHY 203, so make sure you go through the electricity review. We'll make sure that you're able to succeed in the lab. It's really for the laboratory that's important. In this course, what we're really studying, the topics that we're studying for digital logic design, start with what are digital systems, basically binary numbers. Digital systems these days are based on binary systems. So we'll look at Boolean operations and gates, and many of you have done this in discrete math. Then we'll make that extend a little logic function generators and combinational circuit design. Minimizing, a lot of those designs are done with Karnoff maps. Some of you have done that in discrete math as well. Then we'll get into sequential design. This is what tends to be a little more challenging for students. Sequential designs with memories. We'll solve problems using state machines and state assignments, and we'll also look at counters, which are a type of state machine, but a well-defined type. And then, of course, we'll look at representing numbers in different ways in order to do arithmetic, in a computer. We'll look at shift registers and digital computers. So our goal here is that you become proficient in design and analysis of circuits. It is called the design class, so we want to make sure we're looking at the entire design cycle. So that's consists of specification, implementation, testing, and evaluation. So we'll talk about that entire design cycle as well, and you'll make sure you document that in your lab reports. We'll again, beginning with binary systems, numbers representations, Boolean algebra, and combinational circuit design and circuit minimization. And then we'll move on to sequential circuit design, various digital components that we use as building blocks, such as edge and level triggered flip-flops, registers, shift registers, counters. We'll also use a hardware description language. Most digital design now is really done in some type of hardware description language. We'll look at Verilog HDL. We'll become proficient at simulating HDL code and verifying timing diagrams. And we'll be able to use these principles and topics of HDL coding and design and analysis of digital circuits. Attendance policy, you get a bonus point of 3 points awarded for exam if you've attended every class which the material was covered. It has been shown that students that attend class do better. We're doing worksheets in class, so to encourage you, I'm giving you those 3 bonus points. Again, videos and teamwork. Videos are intended as a warm-up. I make these videos that to replace lecture content. So it's a warm-up activity. That's what you do before class to prepare for class, so that in class you can be actively practicing what you looked at, with what you learned, not just looked at, hopefully took notes on in the videos. And you'll be working with some of your peers, so we call it teamwork. You'll be able to discuss it. So that and at the end of the class, you'll be submitting your teamwork, so you'll get a teamwork grade for that. And it just says lowest 5 teamwork grades are dropped. Reading and homework, so the reading, you can go, typically you briefly, go over content before class and really read it more analytically after class as you're doing your homework. So that will be assigned after a class. You want to make sure that you do that homework as soon as possible. You're going to scan then your homework. Typically, you'll handwrite your homework and scan it with your phone, or there's a scanning guideline, and upload it to Blackboard as a PDF. Late homework, I don't really accept late homeworks. I will look over anything that you have to give you feedback, but I won't give you a grade. So, the lowest 5 homework grades then are also dropped. So review the homework guidelines. In your homework and your teamwork, use complete problem-solving process. If you just give the answer, that's 10%. 10% of the grade. That's not very good. So make sure you do the entire problem-solving process, work neatly, scan your work well, leave space for comments. I will give comments. I looked this over. This is a place for, that's my job to give you help you out on your work. So that, it says review homework guidelines as well. Make sure you title your work, put your name. I've noticed once people are submitting things on Blackboard and scanning it, they don't put their name on it. Put your name on the homework and put what the homework assignment is on the homework. We have a 5-step process that we use in the engineering department. We just label out given, find, theory and analysis, solve and check. You don't have to label each of these titles, but given what is the problem, I should be able to look at your work and know what it is you're solving, what you were given in order to solve for that problem. What is the reason that you think you can solve it this way? What's your theory that you're using to do that? In your solution process, I should be able to look at that and be able to figure out if there's an error in that solution process based upon the assumptions you made in the theory that you're using. Then you should go back and check your work. Check your work largely means, does it make sense? What does it mean to you? How can you use that further? Again, exams, there's going to be 4 exams. We will be taking them on the Lynn campus, and they'll be happening during the lab session. So you'll want to make sure you're able to get to an exam. Now you have to sign a wellness contract in order to go to the Lynn campus. So if you're not feeling well, you won't be able to get to the exam. And that can be a problem because no exam grades are dropped. So you want to let me know as soon as possible so we can figure out a way that perhaps you can take that exam anyway. Again, laboratory. Again, students are, you have experiments that you're scheduled to do. Again, we're not going to be doing a notebook. We're going to be doing a report for each of your labs. I will give a makeup lab. If you miss more than one lab, then there's going to be some trouble with that. So we'll have depending upon how the semester goes, we'll have to figure out how that goes. Typically, you just have to have 0 for a lab grade. But you want to try to make it to the exams, but again, only if you're well. You do have to sign that wellness check. Your approach to the labs, it's chapter 9 of the textbook, so you want to read section 9.1. Don't forget to read that. That's the introduction to the experiments for the first lab, for all labs. But the first lab is going to be on Wednesday. That's our very first class. There's lab safety and notebook guidelines and all this into the introduction to lab folder you want to be able to go over before lab on Wednesday. Grading policy, 40% exams, 40% lab, 10% teamwork, 10% homework. We do, accommodations. We have a student support center that will help you if you need accommodations. I can help you get in touch with them if you need that. Common sense, these are Zoom classes, but still, turn off your cell phone. Be there, be present at the Zoom class. Don't, just because you're at the other end of the computer, give that whole hour and 15 minutes that we're going to be in class, give that whole time to your digital logic design class. Read over the syllabus. If you have any questions, make sure you put them together and ask the questions if you can't figure out the answer. It's a Blackboard supported class. Look over the Blackboard. Ask me if you have any questions. Read all instructions carefully, follow them closely, ask questions if you don't understand, but prepare before you ask questions. Prepare before you come to class. Pay attention, actively work, do your homework as soon as it's assigned, and develop a buddy system. Now more than ever, it's so important to be connected. That's a huge part of school, is making connections. So be connected, make connections in class, and give me any feedback. If things aren't working out in this class for you, or that you can see that something's not working out well, let me know. I'm flexible. I'm here. That's my job. I'm here to help you learn. Don't ask for extra credit. There's plenty to do. We're going to have more than enough to do. Don't cheat. There's no reason to cheat. It's really bothers me when people cheat. And keep a record of your own grades. You can check your grades on Blackboard. Use your common sense. You have me as a resource for this class, the tutoring center. I'm not sure how helpful they're going to be. We don't really have students that can tutor this class. Most of them have already graduated. But there are a lot of websites. There's a lot of other material around for digital logic design. The problem with going and trying to access other material is sometimes you get confused in the notation. But it's good to be able to look at other things and try to make analogies and bring those into discussions. You might have relatives or friends also that could help. All right, that's it for this welcome video.